In this class, I'll be solving this question on non-collusive oligopoly. This is question 2. Suppose there are two firms in the market. The market demand function is P equals 100 minus Q, where Q equals Q1 plus Q2. Each of the firms face a constant nominal cost and average cost of $10. Assuming the firm sets quantities simultaneously, derive the firm's reaction functions, that is best response functions. B, determine the profit maximizing output unit of both firms. So if you look at this, you have to pay attention to the assumption. You say, assuming the firm set quantities simultaneously. So that shows that we are dealing with Cournot equilibrium. Okay, we are dealing with what we call Cournot oligopoly. So this tells us that this is a Cournot oligopoly where quantities are determined simultaneously by the firms in the market. So let's see what's going to happen. So to determine the firm's reaction functions, what are you going to do? So we are going to recall the profit maximization rule. Don't forget the profit maximization rule. Profit maximization rule tells you that profit maximization rule is A, tells you that MR is equal to MC. Because we have firm A and because we have firm 1 and 2 here, it's going to be M half 1 equals to MC and also M half 2 equals to MC, because the MC are identical here. Okay, now we know our MC. What of our M half? We don't know that. So we need to derive our M half. So in other words, we know that the market demand function is equal to 100 minus Q. And this same thing can be written as P equal 100 minus Q1 minus Q2. Okay, don't forget Q, this is what I meant. Don't forget Q is equal to Q1 plus Q2. So if I put this in brackets, I replace this with this. So I'm going to be left with P equals 100 minus Q1 minus Q2. Okay. Now I can then derive the total revenue of firm 1. To derive total revenue of firm 1, okay, here, I'm going to have the price, because the common price, multiply by the output of firm 1, which is Q1. So this will give me 100 minus Q1 minus Q2, everything multiplied by Q1. Then the total revenue of firm 1 will be, when I open this bracket, I have 100 Q1 minus Q1 squared, then minus Q1 Q2. So this represents the total revenue function of firm 1. Then I can derive marginal revenue from this total revenue function. In other words, MR1 is equal to the TR1 over the Q1. Okay, because the partial derivative you like, you can just say yes, TR1. So in other words, I have this equals to 100. So I'm going to differentiate with respect to Q1. This Q1, when I differentiate this one, I have minus 2Q1. Then differentiate Q1 here, we are left with minus Q2. Now I can now set this equals to MC. That is MR1 equals to MC. My MR1 is 100 minus 2Q1 minus Q2, which is equals to MC, 10. When I collect the like terms, I have 100 minus 10. Then I take this, then I have minus, because this There is 2q1. This is q1. I want to make sort of formula because this is m1. So I'm going to have minus q2, which is equal to 2q1. Okay, this is 9. This is 90 minus q2 equals to q1. Then I divide both sides by the quotient of q1. I have 90 minus q2 over 2 equals q1. Then I have 90 over 2 minus q2 over 2 equals q1. Then I have 45 minus q2 over 2 equals q1. Okay, so this is the reaction function of M1. Reaction function of M1. Reaction function of M1. Now, since I know that the firms choose quantities simultaneously, and this is a Cournot oligopoly, so the reaction function of other firm, which is firm 2, is going to be symmetry. So it's going to be the same as the reaction function of firm 1 because this is a Cournot oligopoly. So we are now going to say similarly, so Q2 will be equals to 45 minus this will be Q1 over 2. So I don't need to solve for firm 2 because I know this is symmetric. Okay, this is symmetric. So in other words, the reaction function of M1 is Q1 equals 45 minus Q2 over 2, while the reaction function of M2 equal to Q2 equals 45 minus Q1 over 2. So these are the reaction functions of both steps. Okay, so in our next video, determining the profit maximizing output unit of both steps. So see you in the next video. Thank you.